Hello.
To get Francis to join.
Hello, hi Ernest.
Hi. Hope you're good. We're going to start at 7:05 as we wait for any other person who might have wanted to join. Yeah, so we can start. We're going to start with functions. I think Janet, you had requested for functions. So that's what we're going to start with. Yeah. So hello, Janet. Hi, are you there?
It's Juliet. I'm here.
Yeah. Juliet. There is also Janet who is also in.
Oh, okay.
Yeah. Okay. Let's just continue. Yeah. Yeah. I'm back now. Sorry for that. Yeah. So yeah, I was talking about functions. And so what a function is a block of code that is used to perform a specific task in Python. And so you find that we have different types of functions. And so we have built-in functions and user-defined functions. First, before we go on to these two types of functions, just to make it clear what functions are, you see in Python, usually we have the data types. Yeah, we have the flow of control, and you have the functions. Now, among these three, what a function does, function is the piece of code that performs the action. All action in Python are usually performed using functions. Yeah, so function is a piece of code that is used to perform a certain action in Python. And so we have two types of functions. Type number one, we have built-in functions. Type number two, we have user-defined function. And so built-in functions are functions that come with Python. They are already built into Python. And so once you install your Python programming language, these functions are available for you to use without having to create them. So they come up bundled together with Python. And so an example of a built-in function is the print function that we looked at, because you find that that function is already built, is already available for anyone to use. We have also the help function, we have range, we have len. There are so many of them, and we'll be able to encounter them as we just proceed on with the modules to come. So that is built functions that are built into Python and are readily available for any user to use. Next, we have user-defined functions. And so in Python, it's possible for a user or a programmer to create his or her own function, right? And so the reason why you'll want to create a function is because, you see, functions usually provide for code reusability. By reusability, we mean that, let's say you create, let's say in this case, in the case of the print function, you see, developers who created Python language created code for print, for the print operation. Yeah, created several lines of code under the print function. And so this made it possible for anyone to be able to perform the print operation without having to write that code all over again. And so instead of you writing the print functions code all over again, you're provided with the print function. And so whenever you want to print, you just have to call the function name and the parenthesis. Inside the parenthesis, you place the data that you want displayed to you. Yeah. Oh, Janet, you can't hear anything? Hi, Janet. Juliet, can you hear me?
Yes, I can.
Oh, okay, thank you. So Janet, I think, yeah, there is something, there's an issue with your network maybe. Hi, Janet. Okay. Let me just chatter. Let's just wait a bit for Juliet. For Janet, sorry. So hi, Janet. Are you able to hear? Okay. Hi, Janet. Hello, Thomas. Welcome. Oh, welcome, Benson. Okay, so kindly confirm if you can hear me. Okay. Thank you, Benson.
Hi.
Hi. Karibu. Yeah, so we can just continue since Janet has been unable to join us. So yeah, so we were in functions, and so we said that a function is a block of code that is used to perform a certain action in Python. So we said that in Python we have the data types, we have the control structures, and we have functions. And so what functions do, functions are responsible for performing any action in Python. Say you want to print something to the screen, you use a function for that. Any action that you want to do, you do it using functions. And so with the functions, they have one important property about them, in that functions only run when called, right? And so we'll look onto this later on. So in functions, we have two types of functions. Type number one is the built-in function. Type number two is the user-defined functions, right? So built-in functions are functions which come with Python, and anyone is able to use them. They are using universal functions, we can say, in that anyone can be able to use them. As long as you have Python installed in your computer, you can be able to use the built-in functions. Examples of the built-in functions are what we have. We have the print function, we have the help function, we have range function, we have the len function, and many more that we're going to learn in the coming up sessions. Those are built-in functions. Another type of function we have is the user-defined functions. And so it is possible for users or programmers to create their own functions in their code. And so the reason why you'll want to create a function will be because functions provide for code reusability. As we gave an example before, is that you see where we have the print function. So inside the print function, we have the code block for print function, for implementing the functionality of the print function, right? And so were it not for functions, say an example, if it was not for functions, for us to have any information displayed to us, for us to perform the print operation, we'll have to write around 10 lines of code for us to implement that operation of printing data into our screen. And so what happened is that the people who were coding Python, what they did, they created a print function. They created a print function with its code block in it. And so they made it possible, having it this way, they made it possible for anyone who wants to print something to just write, to just code, to just write the print function. You just have to write print brackets into the brackets, insert whatever data you want printed out, instead of having to write 10 lines of code for you to perform the same functionality. So they made work easier for us in that now we are able just to use to write print, then the brackets, then inside the brackets we insert whatever we want to print. They made work easier. And so this was possible because of the implementation of functions. And so that's how function enables code reusability. You just have to create or define a function once, then you can use it as many times as you want. And so that's the logic behind functions. I can see a chart. Let me just check. Okay. Yeah. So we have looked at the built-in functions. Now next is the user-defined functions. For user-defined function, as the name defines itself, is that these are functions that are created by users or programmers. And so, yeah. So these are functions that are created by programmers. Just give me a moment. Just. Yeah. So I hope I'm audible enough. It's training currently. So yeah, so we have the user-defined functions. And so it's possible for programmers or users to create their own functions. Just like the people who are creating Python created the print function, the range function, help function. Also, it's possible for us to create our own functions in Python. And we say that the reason why we would want to create a function is to enable code reusability. In that, let's say you have a task. Yeah, you have a task that you know that you're going to be able to carry out that task several times in your Python code. You can implement that by creating a code block that implements that functionality only once. Then every time you want to perform that functionality in your code, you just call the function that you've created. And so functions enable you to write code once, but make use of the same piece of code several times in your code. And so how to create a function in Python, as we saw there, is that we have a keyword def, which in full means define. And so to create your function, you write define def, that is the keyword, then the name of the function, the name that you want to give the function, followed by brackets, as you can see there, then colon. So this is the header of your function. This is the name. This is the defined keyword, which indicates you are creating a function. So after that, you have the colon. The colon is used hand in hand with the space, with the, what we call this, indentation. The colon is used hand in hand with the indentation to indicate that you want to insert or we can say they are used, the colon and the indentation are used to specify that now we are in the body of the above header. In this case, it shows that whatever we write down here belongs to the function hello function. And so whatever code is here belongs to hello function. That is what the colon and the indentation make your work in cases whereby you're using a single page setup where we don't have the cells like in Jupyter Notebook. And so indentation is just used to make your work appear more clear. But usually it must be there for you to specify that the code below here belongs to the hello function. Whenever this code doesn't have indentation, we are indicating to Python that this is a line of code. But when we have indentation, we are telling Python that this code belongs to hello function. Yeah. So yeah. So we say that this code belongs to the hello function. So this is how you create your function. One, use the def keyword, the function name, the parentheses, followed by a colon. After that, we have indentation, which indicates whatever comes below here belongs to the function hello function. And so that's how we create functions. And so whatever comes down here is the code that we want the function to execute when called. Remember, we said that one property about function is that functions run only when they are called. Functions only run when called. And so, as you can see, in the case of the function that we have defined here, when you run this cell, the hello world statement is not going to be printed yet, as you can see. So if you run this cell, you can see nothing has happened. For something to happen, you have to call the function. And how you call a function is just by writing out the name followed by the parentheses. And so the parentheses indicate that this is a function. That's how you know it's a function. Functions always have the parentheses in them. And so now when we run this cell, when we run the cell, what is going to happen is that the function now is going to execute. Only when we call the function is when the code inside the function is going to execute. But when we are creating it, nothing executes. Only when called does a function execute. And so that's a simple user-defined function that we've created here. And so we created a function that will be able to print the words hello world whenever we call it. Next, we can have our functions with arguments. And so in some cases, we might need to pass in some data into our functions. We might need to pass in data into a function. And so this data which we pass into functions are what we call arguments. And so this data that is going to be passed into our function is going to be used for some operation that you define inside a function. Yeah. And so down here, we were able to create a function with arguments. A function that is able to accept data, process it, and give us some results. That is what we call a function with arguments. And so an example, let's take example in the cell number 9 down here. This is a good example. And so it's the same way we created functions is what we're going to use for this also. Use def for define, and this indicates that you are creating a function followed by the function name. And remember, function names should follow the same conventions as variable names. After that, the special thing about function is that they have the parentheses coming after the name. Then one special thing about functions with arguments is that usually they have a variable inside the brackets. And so this variable that you can have it in any other in any value that you want, in any variable that you want, any name that you want, you can insert there. And so this variable inside the brackets indicates that we are expecting some value, right? So this indicates that we are expecting some value to be passed into our function. And so that value is going to be stored into the variable y once passed into our function. And so that y, that value is going to be passed into our function, and some operations are going to be performed on it. And so as you can see, we have operations down here. In this case, we want to square y and then return the result as an output. And so in the case whereby, let's say we call this function as we did with the above function. As you can see in the above function, we never had any data passed into our function inside the parentheses, but it was able to execute. But in the case whereby we have functions with arguments, it's a must for us to pass in some value into the function. And so we can try something out. Let's define our function. We have created it. Then now we can write the function name, my square there, then brackets, and try running this. And so when you run this without passing in any value into it, it's going to give us some error. And you can see the error is specifying that we are missing one required positional argument y. And so this indicates that the function is expecting some value, but never got the value it was expecting. And so for this kind of function to run, you have to pass in some values. Say we pass in 50 and run. Now you can see what the code that is inside the function's code will execute. And so what will happen is that 50 is going to be passed into our function code down here, and the operation is 50 squared is going to be performed. Then we get the result as Z, which is 2500. After that, we'll have to return some value. That is, we'll have to return some output to the user. So let's say in the case whereby we never had this portion of the code. Let's run that. Then we pass in some value into our function. So when we run that code, you can see we have no outputs given. And so the reason for this is that we have not instructed the function to return any output to us. And so for us to be able to return value to the user, we must include the return keyword and the value that you want returned to the user. That way. Also, sorry. Yeah, is what I wanted to point out. Also, in place of return, you can also use the print function so that we can return some value to the user. We can display some value to the user after an operation has been carried out. So in this case, you can use print, or you can use return, then the value that you want returned to you, to the user. So print and return can be used interchangeably without causing any effect in your function. And so you can return, but for print, mostly is used whenever we want to print strings. Is mostly recommended whenever you want to return a string value as your output in the function. For return, it's mostly recommended to use return when you're dealing with numerical operations. Let's say you want to return a number as an output of your function operation. You use return. For print, you use it when you want to print out string values. Let's say a statement, text, name, and so on. You can use print. That is the most recommended one. So for this case, here we are performing a numerical operation. So we are going to use return for this. And so Z is going to be returned back to the user as an output. That is a function, those are functions with arguments. And so one thing about this is that there is no limit to the number of inputs that a function can have, in that we can have as many inputs as you want, but you have to separate them using a comma. Let's create, down here, we can create a new function. Let's use the define keyword, and let's let's create a function that adds two numbers that we provide to it, or we can say add three numbers that we give it. So def, then add as the function name, add. Inside the brackets, we are going to indicate that we are expecting three values. And to do this, we have to indicate that using variable names. you can say we are expecting an X, a Y, and a Z in this function. Remember again the colon, then go to the next line. Now we are going to write the code that is going to be to perform the operation that we want the function to be able to do. And so down here we can have something like the S is equals to X plus Y plus Z. Then we want to be able to return a result. We want to be able to return the results after the operation has been carried out. And so we want to return S after the operation has been carried out. And so when we run that cell, the function is going to be created. And now it will be available for us to use. And so to use a function, we have to call it. And how we call it is by writing out the name followed by the brackets. Then for this is a function that is expecting some value. And so for this function to run, we are supposed to provide it with the values it requires. And so we are going to provide for it 3 values. Let's say we want to add 5, 6, and 7. We want to perform this operation. So we pass in 3 values into this function. And so when we run that, it's going to give us the answer of the addition between these 3 numbers there. So let's say in the case whereby we pass in 2 numbers, let's see what will happen. You can see it's saying that it's missing 1 required positional argument. So this indicates that for functions, it's a must that you pass in the number of values that are required into it. So when if you define that the function requires 3 values for it to work, then it's a must for you to provide it with 3 values. Any value less or more than the specified numbers will generate an error in that case. And so that is user-defined functions. Also, under user-defined functions, we have the lambda function. And so what lambda function is in simple language is that it's a function with no name. It's an anonymous function in this case, a function with no name. And so one use of a lambda function is you'll want to use a lambda function whenever you want to perform a certain operation only once in your code. Yeah. So let's say you want to perform a certain operation. We can say an example like down here, what we did. Say we want to find the squares of numbers, right? So one way we can do this is by defining a function, as we did above there. We can create a function that expects some value in it. All right. Yeah. Yes. Yes, Juliet. So with arguments, you can use any data type for arguments. In this case here, we can let's pass 0.5, 6, 6.4. and run and see. Yeah, you can pass any argument. It just depends on the operation down here. And so in the case whereby, let's say you pass in string values into this function, another type of operation is going to occur in here. Let's say, for example, let's pass in string values. Sorry, let's pass in a. Let's pass in these strings into this function of ours and see what will happen. You can see when you pass the strings into a function, the operation that happened is no longer addition. So the operation that we have indicated here happens depending on the data type that you have passed into your function. In this case, the plus operation in strings is usually the concatenate operation. And so it combines these different string values into one. That is what the addition sign here means for strings. But for float values, it's going to perform addition operation. For integer values, it's going also to perform the addition operation for that. So you can pass any data type into your functions unless you specify that you need a certain data type into your function. Yeah, right. So we were looking at lambda functions, and we say that a lambda function is a function with no name. And so what a lambda function allows you, or an application of a lambda function, is we can say it allows you to make use of the function functionality. You can say something like that. Yeah, it allows you to use the function functionality or properties, but in this case it only allows you to use a function only once in your operation. As we indicated here, say we want to find the square of two numbers, right? So one way we can perform the square operation, we can create a function. We can define a function for that. And so we defined here a function that is going to return, is going to take in the value x and return the value x multiplied by itself. And so this will result into a function. And so that's what we did. Then we passed in the number 3. So after doing this, number 9 is going to be returned as our result or our output in this case. But say in the case whereby you want to make use of a function only once. And so in cases like, let's say you know that the square operation is going to be needed in your code, or to appear in your code only once. You're going to be required to perform the square operation only once in your code. So for that, you can be able to use the functionalities by making use of the lambda function for that. And so in cases where I want to use the function only once, there won't be any need for me to define a function, because when you define a function, you expect that you want to make use of that function over and over again. You're going to reuse the functionality of that function over again. But for lambda function, you create it once, use it in that instant, then leave it alone. You go on to the next work that you're going to do. And one thing about Lambda function is that you're not able to reuse it in your code. And so Lambda functions have a certain syntax that is different from from the usual functions that we looked at. And so for you to define a function, a Lambda function to be specific, you start with the Lambda keyword. Lambda is a keyword, followed by the arguments. That is the values that you want passed into your function. Arguments, then we have a colon separating arguments, and then expression. So what is going to happen is that the Lambda function will be able to take arguments and pass the arguments along into the expression where its operation is going to be implemented in the expression. Let's say an example down here, in the case whereby we want to square a number and we want to perform this operation only once. You define lambda, that this is a lambda function, by using a lambda function, the lambda keyword, followed by arguments. So you can have as many as you want. Arguments, then we have a colon. After the colon, we have an expression that implements whatever you want the lambda function to do. So in this case, I wanted the lambda function to be able to multiply a number by itself. In this case, square, to work as a square function. So I wrote lambda a, I'm expecting a value, one value to be specific, followed by colon. After the colon, we have the we want to multiply the value by itself. Yeah, and so that's how a lambda function works. In this case here, you're not able to see the real implementation of a lambda function, because in this case we have given it a name x. We have stored the lambda function into a variable x. In this case, how it works doesn't come out clearly, but we're going to look into this as we proceed on after the map and filter function. So that is lambda function, a function with no name, and it is used to when you want to make use of the function functionalities only once. So next, we are going to look at ways in which we can be able to apply functions into lists. So let me just specify this. So these are ways that we are going to be able to apply functions to lists. As you know, for us to be able to perform any mathematical operation on a list, we normally have to use the for loop. The for loop iterates over a list, performing a given operation on it. And so we can have a look at the different ways we can apply functions to a list. Here we defined a function. We defined our list and give it the name sequence. One of the ways we can apply functions to lists, as I said, is by use of a for loop. So in this case, we want to apply the my square function. That is the function which we created that squares a number and returns its values. And so one of the ways we can be able to perform that is by using the for loop, whereby we iterate over the list, going through each element one by one and performing the square operation. And then for this, let me just make it. Yeah, let me just make it more to be more clear. Say return. Oh yeah. Sorry for that. Yeah, it will work this way. To define this. Want to print yeah, that's what I wanted. So yeah, so one of the ways in which you can apply functions to lists is that by using a for loop, whereby we iterate over each individual element in the list, applying the function to it. And so what's happening in this case here, we have gone iterated over one, squared one, then printed it out as an output. We went to 2, performed the square operation on it, then printed out 4 as a result. So this is one of the ways that we can apply functions to lists. But for this operation, it's a little bit challenging in cases whereby you're using some complex list, let's say a list inside a list, in the case of that. So it has some of its limitation, but it's also good for it. It's also good enough to perform simple function operations on lists. But in the case of lists, we are provided with map and filter functions to perform this kind of operation in a simpler way. And so for map function applies a given function to each individual items in a list or a sequence, and returns an iterator as a result, which we have to convert also to a list. And so by this, what I mean is that what this means is that the map function applies a function to a list or a sequence or any other sequence. Yeah, it applies the function to a sequence. And so the syntax of the map function is map, the brackets, the first argument that is going to take is the function, then followed by the list or the sequence that you want the function applied to. So in this case here, I wanted to apply the function, my square, to the list sequence. I used map for that. So map is going to apply the function to each individual item in that list of ours. So let's a sequence. Yeah. And so one thing about map is that once it performs the operation, it doesn't return to us the result of the operation. Instead, it returns to us the map, that is the memory location in which the new list from this operation has been stored in. And so for us to be able to get the result as a list, we use the list function out here. We pass in the map into the list function for us to be able to convert this memory location to a list and get our list, get the list as our result. So when you run it now, you can see now we are able to get the list that was created from the operation on of the function my square to the sequence list in this case. So that is map. Map just applies a function to a list. Next, we're going to make use of the lambda function. In this case, we're going to apply the lambda function to a list. And so this is where the main functionality, the main use of lambda function comes in. Let's say in this case, you want to perform an operation where you want to add each item in a list by one, right? And so for this, we can also use map, but in this case, you don't have a function already predefined for you. You are not already defined a function to perform that kind of operation. And so this is where the lambda function comes in. So in cases whereby you know that this operation is going to be performed only once, you can create a lambda function. And so in this case, we created a lambda function by using the lambda keyword. This indicates that this is a lambda function. Then after the keyword comes in the arguments. You can have a single argument or multiple arguments. After that, we have the colon separating the expression, which implements the functionality of the lambda function. In this case, I wanted my lambda function to perform the operation of adding each value of the sequence by one. And so this is the expression, arguments, and the keyword lambda. So here I've used map. And so what map will do, will apply this lambda function to each individual items in the sequence here. And so the sequence is a list that we had created, which contains the value 1, 2, 3, 4, 5. And so map is going to apply this lambda function to each item of the list sequence. Then we are going to get the result as a memory address. And so for us to be able to convert that memory address into a list, we use the list function and we pass in the map into the list function. Then we are going to get our result as a list of the operation that has been performed on our previous list. So that is map. Map applies functions